gonna prove the following where n is a positive integer. That is, I'm not gonna prove it for any real number. And the fact is this. Well, let's write it down. Let me list it. If, no I won't. The limit as x goes to a of f of x to the n, where n is a positive integer, is equal to the limit as x goes to a of f of x. Find that answer and then raise it to the nth power. We're going to prove this by induction. Well, of course, if n is 1, it's obvious. N equals 1, obvious. Because it's basically saying that's not here. Because anything to the first power is the anything. Okay. If n is equal to 2, well, you have the limit as x goes to a. So let's prove another base case of f of x squared. Well, this is the limit as x goes to a of f of x, times f of x. So we proved the product rule of two functions. This is equal to the limit of the first function, which is f of x, times the limit of the second function. It's not my fault that they're the same function. So you multiply, I don't care what it is, you multiply something by itself 2 times, you will get that answer to the second power. But that's just what you wanted to show. Okay, so now assume it's true for n equal k. That is, the limit as x goes to a of f of x to the kth power is equal to the limit as x goes to a of f of x, and raise that answer to the kth power. Okay, now we must show for the next n. We must show for n equal k plus 1 that the limit as x goes to a of f of x, not to the kth power, but one more, why that equals to the limit as x goes to a of f of x, and raise that whole thing to the k plus 1. This equal sign is what we have to verify. Okay, so the limit, let me start off with the left. The limit as x goes to a of f of x to the k plus 1, like, wow, I only know how to deal with k's and the product of 2's. Well, this is the two function. Yeah, product. This is the limit as x goes to a of, say, f of x to the k times f of x. Now, f of x to the k is the function. I'm not saying we know the limit of it, but it's the function times another function. I can use the product rule here. I may not know what the limit of this is. Maybe I will though. The limit as x goes to a of f of x to the k times the limit of the second function. And this is where everything comes together. by assumption, if the power is k, this limit is our induction hypothesis. This is the limit as x goes to a of f of x all to the kth power. And this here is a real number. Limits are real numbers. I guess we should have said that the limit is finite and exists. I can say this is to the first power. Again, I don't care what this is. You raise it to the kth power, and you multiply it to the first power. You're going to have whatever that mess is. In this case, it's that raised to the, well, add the powers. K plus 1. That completes this theorem.